Hey guys, in this lesson we would understand how to calculate the length of a line segment and what are its applications. Let's say we are given a line segment and we are asked to find out what is the length of this segment. There is a formula to find the length of a segment as well. That formula also uses the endpoints of the line segment. So if you're given the first endpoint as x1, y1 and second endpoint as x2, y2, length of the line segment is a square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula that we would be using for finding the length of any line segment or any line for which we are given the two endpoints. And this length formula has lots and lots of applications when it comes to different geometric shapes. Let's say we're asked to find the length of a line segment with endpoints given to us as -3, 4 and 2, 3. To find out the length, we would use this formula. Let's call this x1, y1 and let's call this x2, y2. We need to find out the value of x2, that is 2, minus value of x1, that is -3, and square this entire thing, plus y2 is 3 minus y1 is 4. Again, we have to square this whole thing. Now we just have to solve this. So 2 minus and minus is plus. 2 plus 3 whole square plus 3 minus 4 is -1 square. This will give us 5 square plus 1. And that finally gives us 25 plus 1, which is square root of 26. Square root 26 is 5.1. Therefore, the length of the line segment is 5.1 units. Because it is the length, so we have to put some units there. And we're not specified what units to put, so we just put units as is. Let's say we're asked to classify the triangle on the basis of side lengths. So all we have to do is to figure out if this triangle is an equilateral, scalene, or isosceles triangle. Now in order to do so, we just need to find out the length of each of these line segments that is formed by the vertices of the triangle. So let's call this line segment 1, line segment 2 and line segment 3. And let's find the length of the first line segment. Let's take this as x2, y2 and this is x1, y1 and let's call this as x3, y3. So we would do x2 minus x1, which is 3 minus 1 square plus 8 minus 2 square. That would be equal to square root of 2 square plus 6 square, which is equal to 4 plus 36, that is 40 square root. Similarly, we would find out the length of the second line segment, which is this. In this case, we would do x3 minus x1, so 6 minus 1 whole square plus 4 minus 2 whole square, and we would get 5 square plus 2 square, which would give us 25 plus 4, that is equal to square root 29. Next we are finding is the length of the third segment, and that is this one. Let's take it as x3 minus x2. So it would be 6 minus 3 whole square plus 4 minus 8 whole square, and this would give us 3 square plus minus 4 square, that is equal to 9 plus 16, which is square root 25. Now when we look at these three lengths, length 1, length 2 and length 3, none of these lengths are equal to each other. Therefore, when the three lengths or three sides of a triangle are not equal to each other, it is called a scalene triangle. Hence, this triangle is called a scalene triangle. This is how we use the length formula to classify a given geometric shape.